we go. We're going to start on Chapter 3. And I want to give you a little overview of what Chapter 3 is going to look like. So, basically, in mathematics, you learn about all these different inverse operations so that we can solve equations. So, like early on in math, you learn about plus and subtraction. They're inverse operations, right? And then we have times and we have divide. And we use these all the time to solve equations. Well, after a while, you have to start coming up with other inverse operations to solve things. Like, for example, if you have, like if you have squares, how do you deal with those? Well, then you need a square root. Okay, those are inverse operations. Now, if you have x cubed, you need somehow to undo this cube. So what we do is we call it a cube root. But this time we write a little 3 in there. That tells us that we're dealing with cube roots instead of square roots. And if you had x to the fourth, you'd have to undo x to the fourth. And so we use what's called a fourth root. And these, like I said, those are inverse operations. Now, normally when you do the square root, I should say something about that, you can think of it having an index also with a 2. But over the years, we've called this one the default. And so everyone knows that if you have the square root, you don't have to necessarily write the 2 in there. So over the years, we stopped writing a 2 in there. But all the other ones, in order to not be confused with which root you're doing, we have to put the index in there. So when you look on a calculator keypad, you're going to see 2 boxes on there. One, you're going to see the regular square root, which has the index of a 2, but we never write it in there. And another button that has an nth root. So they'll put an n right here. And in that case, you have to tell the calculator which root you're dealing with. Does that sort of make sense so far? Now, another thing I think is handy for this whole chapter is just being familiar with some of these cube numbers and the numbers that are to the fourth power. So I recommend doing this somewhere on your paper. Okay, you guys ready? I'm going to do a new page now. We'll make a list of some numbers that come up. N squared, n cubed, n to the fourth power. If you have your study guide, you could probably write this on your study guide somewhere. And you want to be familiar at least with maybe the first 7 or so. Like when n is equal to 1, okay, n squared would also be 1. N cubed, no, it'd be 1. And that'd be 1. You see, what about 2? Okay, well, 2 squared is 4. Yeah, I'd make a table somewhere just as a reference, at least in the beginning. N cubed here would make this, yeah, some people will say 6, but we're not multiplying, we're doing an exponent. So it's 2 times 2 times 2, which makes that an 8. And this one's 16, right? How about 3? That's 9, of course. 27, 81. How about 4? 16, 64, 256. How about 5? 25, 125, 620, 625. And how about 6? 36. No. I think it's 216. Can someone check? And what's this one? I think it's 7. Oh, 1228. 1228? Oh, 1296. Yeah, this starts 1296. Okay, so you get the idea. Well, we could keep going if we want. 749, 343, and then I don't know the fourth power one. 2401? All right, so this will come in handy as we solve some equation. I'm going to show you how in just a few moments. Well, hopefully you have that written down somewhere. And now I think I'm ready. I've given you some background about the chapter and how it's going to work. And now let's go ahead and go through our PowerPoint a little bit slower and learn some properties. You're going to learn all the rules now. And I've written down some of the rules on the whiteboard already. So anyhow, let's take a look at it. This looks pretty cool. Looks like a compass of some sort. I know. Cool stuff. Okay, here's the objective. Those of you doing Cornell notes can write this down. Students will be able to solve equations involving nth roots. And so a natural question would be, how do you do that? How do you solve equations with nth roots? All right. Part of what we need to learn are different ways of writing things. There's certain notations we use. And so, as I was saying earlier, if we put a number in here, it tells us which root we're dealing with. And so that number in there is called the index. So these are a couple properties that we have, and they're the same properties we had before, except for now we're going to be dealing with fractions. I'd like to explain why we have fractions now. So let me go take a little side trip for a second. The square root. If I have the square root of x, this is what we call radical notation. Radical. And so there's another way we could write this. We can write this way or this way. And we can write this as x to the 1/2 power. Now remember, the index for a square root was a 2. Okay, it's just we don't write it in there most of the time. And after you see a couple more of these, I think you'll figure out the pattern. If I show you the cube root of x, and I write it in exponential form, I'd write it as x to the 1/3. It's a fractional exponent. Fractional exponent. So can you guess what this one's going to be?
X to the 1/5.
X to the 1/4. There you go. See, how about that?
How
about this next one? 5th, x. These are all equal, right? These are all equal. And so this one would be x to the 1/5. So hopefully you recognize the pattern. All you do is take the index and put it over here and put it in the denominator. Does that make sense? Yeah, pretty easy stuff. Okay, so now let's go back to our PowerPoint and see this property now. So the thing is, there every time you have these cube roots or fifth roots or whatever roots, you have what's called a fractional exponent. And so now we're going to learn some exponential rules. And this rule that we're talking about, number 1 right here, it's the same one we had before. When you had x squared times, well, let's see, we raise it to 4. What did we do? We multiplied the exponents, right? And so we get x to the 8 power, right? Well, it's saying the same thing. If you have a fractional exponent raised to another exponent, you multiply. Okay? So if you multiply 1 over n times n, you get that. Now, what we're saying here is that this is equivalent to the radicand notation. You have the radical notation, you have the fractional notation.
What's better?
Well, in some cases you want this kind, in some cases you want this kind. So as we work through the chapter, you're going to see the differences. Oh, we also have this negative exponent rule. That's the same thing we had before. Like if you have x to the -5, that's equal to 1 over x to the 5th. And so when you move the exponent down to the denominator, it changes to positive. Okay? So the same is true if you have a fractional exponent, it goes down to the denominator and becomes positive. And likewise, if you have a negative exponent here and you move it up, it changes sign also. So I often refer to this as the elevator trick. Anyhow, this will probably make more sense once we start dealing with some problems. So let's look at some of these. Okay, so I need to pick a color that's going to work here. All right, so when we see these problems here, we want to evaluate. And the basic idea, what you want to do is take this base here and rewrite it so that it cancels off the denominator of the exponent. So the way it cancels off is by looking for a cubed number. So can you think of a number, and that's why yeah, 5, right? If you rewrite this now as 5 cubed, and then you raise it to this power right here, 2/3, then the property that we're going to use is multiply the exponents. When you multiply these exponents, the 3 cancels off this 3, and so you get 5 squared. Ooh, you can't see that very well. So let me switch colors to white. Uh-oh. Whoops. It's equal to, you see the 3's canceled, and you get 5 squared, right? And so then in this case we get 25. There you go. We've evaluated. All right, and we'll try this one now. So in this one, you want to cancel out the 3 here. You see there's a 3 down here. So that gives us a clue on how to rewrite this. Now, yeah, use 2, right? Because this is equal to, whoops, blue doesn't work so good on that one. So we're going to write this as 2 cubed raised to the negative 4/3 power. And the property that we were just learning about, when you have an exponent raised to an exponent, you have to multiply the exponents. So in that case, the 3's would cancel. And so then this is equal to 2 to the negative 4. Well, just as we were doing in chapter 2 when we were dealing with exponents, we will continue the same tradition. Yeah, you don't want to have negative exponents. So we want to rewrite this as 1 over 2 to the 4th. And of course, that's 1 over 16. Okay? Well, now I think we're ready to start doing our study guide a little bit. So I'm gonna stop, and we're gonna switch, go to our study guide here. And I think what you can do are these first 4 problems here, 3, 4, 5, and 6. So I'm gonna pause the video. So now there's a very interesting question here now that we should ask. We're getting pretty good at this. What happens? Is my pen working? Sometimes my pen doesn't. Okay, there we go. What if we change this problem just a little bit so that it says 15 to the minus 1/4? What then? You're trying to find a number to the 4th power that's going to cancel out that denominator. Most of us don't know those kind of numbers off the top of our head. So for this type of problem, we're going to probably use a calculator. So when you're doing this assignment and you're taking the test, make sure you read the directions. Because on some problems you're going to be using a calculator and you're expected to. In other cases, you're not expected to use a calculator. You're supposed to show that you understand the properties of exponents. Okay? Does that sort of make sense? So let's take a look. If you go to the next page on your study guide, you start to get to some of these like this, where you're going to eventually be solving equations. And let's move on to number 7. And I'll just mention, when you're using your calculator, you're going to look for 2 different buttons. Okay? For this one, for example, you have to look for a button that has an in here and a square root like that. Okay? Now, the way you use this button, you're going to hit the number 6 first. You tell the calculator what the index is first. So you hit that button, 6. Then you hit the button that looks like this. So it goes like that. And then you're going to put the 13 inside of there. Does that sort of make sense? So try this in your calculator and see. So, did you guys get number 8? You should get, we're going to go to 2 decimal places, right? What did you get? 1.53. Okay. Now, this one's pretty easy. You just use the caret button, okay? And then put in that exponent, okay? What do you get on that one? 10 to the 1/3 power. Try all these we're going to do with our calculator. 10 caret 1/3. Does anyone need to see me do this on the calculator? Okay, so I'm going to pause the video because I can't record the calculator moves here. So number 10, maybe you could try it both ways, with a calculator and without a calculator. Okay? So, yeah, let me work out this one, please. Without a calculator, it's going to look like this. I want to rewrite this. You see? Oh, I gotta switch screens. Duh. Okay, sorry. Sometimes it's clear on my screen, but not clear on your screen. Okay, so we're back here now. So you got 1/9, right? If you use your calculator, 1/9. Let me show you this one now without a calculator. Okay, so we have the index is 4, right? And we have 81 here, and we have -2 here. Now remember, I can go to fractional exponential form. I could write this as 81 to what power? To the 1/4 power. Remember, this goes in the denominator, right? And then you could write that to the -2 power. Now remember, when you're doing it this method, if you know a number that's to the 4th power, you can cancel off that denominator. How about 3? So you could then write this as 3 to the 4th power to the 1/4 power, and then write that to the -2 power. And now, in this situation, you multiply the exponents so they cancel, and so then you end up with 3 to the -2, which of course is 1/3 squared, which is equal to 1/9. Now, this is why it's going to be important. If I ask you to do this with a calculator, boom, you're done. You get 1/9. But on the test, I might be interested in seeing if you know the properties of exponents. Do you know how to simplify things? And so make sure you follow the directions, because in this case, if you did this with a calculator and I asked you not to, you get a 0. You did not do what I was hoping to see. So, any questions? All right. So let's go back and try to do a few more here. Okay, starting right about here, we start dealing with equations. And these, you start out the same way you normally would, solve an equation. Like, I think what we do here is get rid of this -6 first. By -6 here, right? The -6 cancels, so then you have x squared is equal to negative divided by negative is a positive, so what is this, 36? No? What is it? Oh, it's 30. Now, the inverse operation of a square is a square root. So hopefully you understand that this problem we're going to do a square root. Okay? Because that square cancels out the square root. So now we have x. And now we have the square root of 30. And what do we get? Square root of 30 is what? 5.48. Okay, there's just one other little nuisance we have to deal with. When you have a squared number and you're doing a square root, technically you can have two answers. Well, let's say we had the x squared is equal to 16, right? I want to demonstrate this. Please pay attention. If I have x squared is equal to 16, aren't there two values of x that would give me 16? Yeah. X could be equal to 4, right? Because 4 squared is equal to 16. But x could also be negative 4, because negative 4 squared is equal to 16 also. So when you get ready to do your square root or your inverse operation, here's something you have to do when you have a square root. When you take a square root on both sides of an equal sign, you have to put in a plus or minus. Does that make sense? Because you should have two answers. So when they cancel off here, that's fine. You have x. And in this case, you have plus or minus 4. Does that make sense? Well, we have to take the same care on this problem here. We actually have plus or minus 5.48. That's kind of a ticky-tack thing that you have to worry about. The cubes don't, it's different for cubes, right? In fact, it's different for any odd-powered one. On the other hand, this one we have the same issue. Something to the fourth power. If I have x to the fourth power equal to 16, you could say the answer is x equals 2, right? But couldn't you have x equals negative 2 also? I mean, negative 2 to the fourth power is equal to negative 2 times negative 2 times negative 2 times negative 2. And that equals 16 also. So that's the thing you have to watch out for in this chapter. If you have an even number as the exponent, and you're trying the inverse operation, which in this case is a square root. In some cases, you'd have a fourth root. Or in some cases, you might have a sixth root. Anytime this is an even index, you're going to have a plus or minus. If it's an odd number, then you only have one answer. So please contrast the difference between 11 and 12. This time you don't have a plus or minus. Okay? So that being said, let's do number 12 and try to get that one done. And then what let me get to it and see if, let me do it step by step. So number 12, first thing we're going to do is add 9, right? Add 9 to both sides of the equal sign. And that gives us x cubed is equal to 40, right? Well, to undo this cube, I have to do the inverse operation. And in this case, the inverse operation is a cube root. Well, that's an odd index, so I don't have to worry about plus or minus this time. I need to do a cube root here. And you learned how to do this in a calculator, right? Yeah. So we get x is equal to... You sure? It can't be 18.
I got 18.
No, you didn't. You did a cube root. You did 3 times the square root of 40. You got, remember, to do the cube root, you have to put the 3 in first, and then you need to hit the button with an N. All right, what did you get, Michaela? 3.42. Sounds right. All right. All right, see if you can finish up the rest of the study guide. Now, tomorrow, we will have a substitute, so I don't know. What are you saying yeah for? Yeah, that's better. No, you take the fourth root on both sides. Because you want to cancel out that 4. Make sense? Yeah. So, tomorrow, there might be the possibility of snow tonight going on into the morning. So, I don't know if we're going to have a delay or not. So, I'm going to give you guys a puzzle to work on tomorrow. Now, you will have two puzzles more than likely. Just listen, let me finish. So, let me stop this because they don't need to know.